Hello, welcome back to my channel. So today I'll be going over molar mass and percent composition. So in chemistry, when it comes to molar mass, it's basically grams. So we know mass is measured in grams, and we're talking about elements and compounds of the periodic table. So what molar mass is a mass of any given substance in 1 mole. And if you remember what mole is, I like to think of it as a thing. So everything of something weighs a certain mass. So if we look at our periodic table here, so if we look at the atomic mass, it's similar to molar mass. So let's just look at silicon here, so it's like easier to see, it's bigger. So the atomic mass of silicon is 28.086. So that's the same thing as molar mass. So what that means, so every 1 silicon has a given mass of 28.086. Alright, so how to calculate molar mass of compounds is you basically just add compound or elements together. So for example, if I want to give you the molar mass, or ask you to find the molar mass of H2O, you have to find the mass of H and O, and then you will add them together. So if we look at hydrogen, the mass for that is 1.008. But then if you look here in H2O, there's 2 hydrogens. So we have to multiply that by 2. That'll be 2.016. And then if we look at oxygen, and there's only 1 oxygen, so that'll be 15.999. And these are the molar masses separately for each element. And if I want to ask you the molar mass for the entire thing, you simply just add these together. So when you add 2.016 and 15.999, you should get 18.015. Or not 15, I'm sorry, 18.015. And the units for that is grams per mole. So what the unit tells us is that every 1 water, every 1 H2O has a mass of 18.015. So 18.015 grams in 1 mole. So I'll give you another example. Should be a lot easier here. NaCl. You have sodium and you have Cl. So sodium has a mass of 22.990, and chlorine has a mass of 35.453. And then you simply just add those together, and you should get 58.443 grams per mole. It's as easy as that. And the reason why I'm teaching on molar mass, because this is important to figure out percent composition. So now we're going to move on to percent composition. So percent composition is essentially telling you how much of an element is in a whole compound. So if you think of the percents in general, what that means is that it's like parts over whole, and then you multiply that by 100 to get that percent, right? But in chemistry, I'll just say chem, you're going to take your mass, or the molar mass of your elements, whatever the compound that is. You're going to divide that by your mass of your entire compound. And you're going to multiply that by 100. So I'm just going to take this example first, since we already have our numbers here, and then I'm going to give you an example where you calculate everything by yourself. So for example, if I ask you, what is the percent composition of Na in NaCl, what I'm asking is how much of sodium is in sodium chloride. Because you may think, oh, it's Na and Cl, it's 2, so it may be 50-50, right? But that's not true, because if you look at the molar masses of these two elements, chlorine has a bigger mass than sodium, so it's not 50-50. All right, so I'm going to use this equation here to figure that out. We have our mass of sodium over your mass of NaCl. Again, you don't have to write all of this out. This is just, a first example to figure out, just to show the work step by step. And then again, you multiply by 100 at the end. So my mass of sodium is 22.990 divided by my mass of my entire compound, divided by 58.443, and we're going to multiply that by 100 after we divide that. So when we do that, we get that decimal here, and you got to remember to multiply by 100. So I would round to 2 decimal places, so 39.34% of Na. So what this tells me is that in this compound, about 39% of the mass is sodium. And if we do the percent composition of chlorine, we do the same thing. We have our mass of chlorine over our mass of our compound, NaCl. So my mass of chlorine is 35.453 divided by our compound mass, 58.443 times 100 equals it is 60.66%. Alright, and a good way to check your work, because percent means out of 100, right? So these two percentages should equal to 100, or really, really close to 100. So if I just check my work, so 39.34 plus 60.66, look at that, 100. And you may sometimes get like 99.99 or 100.001. As long as you don't get like 102 or like 97, that means you're off. So it should be really, really close to 100. Okay. Now I'm going to give you one example to try by yourself. What is the percent composition of nitrogen in NH3? Alright, so you're going to try this by yourself. I will freeze the screen and then unfreeze to check your work. And you will, also I would pause this video, try it by yourself, and then unpause to check your work. Alright, so this should be your answer here, 82.24%. So basically, I got the mass of nitrogen from periodic table, 14.07, and to the side I found the mass of NH3, so I got that as 17.031, plugged it in, and I should get 82.24%. And then if you're to do hydrogen, if you subtract by 100, it should be the percent composition of hydrogen. Alright, so that is it for molar mass and percent composition. I hope this helps, and hope you have a wonderful day.